Hey everybody. Okay, so here's the lesson for today. I'm going to do this one a little bit different than I've been doing the last couple of weeks. I'm actually going to make two separate videos that are a little bit shorter. And the reason I'm doing that is because it's taken me a long time to upload these to YouTube, and that's sometimes why the videos are late getting to you guys. So I'm going to make two smaller ones, and then hopefully they'll upload faster and I can get them to you on time versus being, a few hours late. So what I'd like for you to do first here is we're gonna do some pattern work. So I've started a pattern here, and what I'd like you to do is to figure out what this pattern is and then just continue the pattern going down and continue the pattern going up. This is not something you need to turn in to me. I'm not gonna ask you to turn it in with your homework. I just want you to work on it here, and then we will come together in just a moment after you've press pause and then restart again. We'll come together and see what kind of patterns you came up, and you can see the pattern that I came up with. Okay, so go ahead and take a moment to press pause and then see what kind of pattern you can come up with. Okay, so I'm sure you had a chance to do it, so I'm just gonna show the pattern that I see. I'm not necessarily saying that my pattern is better than anyone else's, but this is just the way that I see it. So what I see is I go, okay, if I go from here to here, that's multiplied by 2. And if I go from here to here, that's multiplied by 2. So that seems like each time what I'm doing is I'm multiplying by 2. So I think that's probably what my pattern is. So I'm going to say the next one is going to be 32, and then 64, and then 128. Okay? So each time what I did was I multiplied by 2 and I multiplied by 2. So if I'm going to look at my pattern going down here, I'm not multiplying by 2. It looks like if I were going to go from 16 to 8, that would be divide by 2. If I'm going from 8 to 4, that would be divide by 2. So I think if I'm going from 4 to this one, that's going to be divide by 2. So then that would be 2. And then I'm going to do another divide by 2. And that would be, whoops, didn't mean that to be red. I want that still to be blue. And then I see another one that is divided by 2, so that's 1. And then if I continue to divide by 2 here, that's going to be 0.5. And the next one would be 0.25. And the next one would be 1.25. Excuse me. 1.25. And the next one is going to be 0.625. And the next one's going to be whoops, did that one wrong. It's going to be 0.3125. And the next one's going to be 0. I don't even know. I'm just gonna leave that one blank. All right, so whatever that divided by 2 is, I could probably work it out, but I think that's probably good. Okay, so so there's our each one here. If we're going down, it looks like we're dividing by 2 each time, and if we're going up, it looks like we're multiplying by 2. So if I multiplied this by 2, that would get me to 6.25. Multiply that by 2. 0.125, 0.25, 0.5, and on down. Okay, so pretty good, right? Notice I got some color coding here. I've got the numbers on top that are blue, the numbers on bottom are red, and then right there in the middle is green. All right, so I'm gonna pause it for a moment. I'm gonna put up another pattern and have you guys see if you can figure out what that pattern is. Okay, so here's the next pattern I'd like for us to work on. And again, I got a few at the top and a few down below. So we have 2 squared, 2 to the third, 2 to the fourth. I'll make that look like 2 to the third. Looks like it's 23. So I have 2 squared, 2 to the third, 2 to the fourth. Go ahead and tell me what you think the ones up here would be. And then, of course, the ones down below would be. All right, so go ahead and press pause and then fill those blanks in, and then we'll come back together in just a second. Okay, so I'm sure you had time to do that. This does not look like a terribly difficult pattern developing. So if I got 2 squared, 2 to the third, 2 to the fourth, I'm guessing this one's going to be 2 to the fifth, 2 to the sixth, and 2 to the seventh. Okay, so I just see it going up by exponent of 1 each time. So that means it'd be going down by an exponent of 1 each time. So then this would be 2 to the first, which we don't really write that 1, but I did it for emphasis. And this is where it gets a little bit tricky. So the next one, of course, would be 2 to the 0, right? And then it really starts to get tricky. So this is going to be 2 to the negative first, and 2 to the negative second, and 2 to the negative third, and 2 to the negative fourth, and 2 to the negative fifth. Okay? So if I look at this pattern, what I have developed here, I have each exponent is increasing by 1. So I have 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the fifth, 6, 2 to the seventh. And then going down, they're decreasing 1. So that's technically 2 to the first, which we don't really write the 1, but I did. 2 to the 0, then I just go to the negative 1, negative 2, negative 3, negative 4, negative 5. Okay? So, all right. So that looks like the pattern that's developed there. So now what we're going to do is we're going to take a look at both of those, because there's some commonalities here, right? So if I look at what 2 squared equals 4. 2 to the third equals 8. 2 to the fourth equals 16. So the first pattern that we did was actually this pattern, just not written in exponent form. So multiply it out. So 2 to the fifth equals 32, 2 to the sixth equals 64. So that's all nice and neat. What I want to really focus on here is this stuff down the middle. So 2 to the first equals 2, and 2 to the 0 equals 1. And here's what we're going to talk about is this right here. Anything to the 0 power always equals 1, no matter what. If this was 3 to the squared, 3 to the third, 3 to the fourth, when I'm going down here, what I would be doing, this would be 9. So if I divide by 3, that would be 3. If I divide by 3, that would be 1. So every single time when you get to 2 to the 0, it's going to equal 1. Or 3 to the 0, it's going to equal 1. Or 9 to the 0, it's going to equal 1. So I'm going to write that right here in the middle, that anything, so x to the 0 always equals 1. So anything to the 0 power equals 1. It doesn't equal 0. It equals 1. Okay, so anything to the 0 power equals 1. And then what I really want us to notice is what happens after we get down below 0, right? So here's where we have negative exponents. And how are these numbers compared to 1? So that's the next thing I want you to think about is look at all the blue numbers up above, and how would you describe all of these numbers compared to the number 1? And then look at the red numbers, and how would you describe all of those numbers compared to the number 1? So some might say that all the numbers up here are all bigger than 1. They're all greater than 1. All the numbers down here are smaller than 1. Okay, they're less than 1. Notice that none of these numbers are negative though. This isn't negative 0.5 and not negative 0.25 and not negative 0.125. They're just smaller than 1. So that's a critical thing. When we're talking about exponents, we have things that are either greater than 1 or we have things that are less than 1. It has nothing to do with positive and negative though. So then we come over here and look at this, and how do we determine that? Well, all the numbers that are less than 1 have what type of exponents? They have negative exponents. So if you see a negative exponent, does that mean a negative number? And the answer to that is no. Negative exponents do not mean negative numbers. Negative exponents means less than 1. So it's some decimal of, compared to 1. So it's not equal to 1, it's smaller than 1. This negative 3 is less than 1. It's not negative 0.125, it's just 0.125. And if the exponents are positive, then all those numbers are going to be greater than 1, right? So all the positive exponents are greater than 1. All the negative exponents are less than 1, but not a negative number. That's the biggest misconception. The students think that negative exponents mean that my answer is negative. That's not true, okay? So now I'm going to take a look at one other quick thing here. And I'm going to kind of erase a little bit of this stuff because I think we've got it, but I'm going to leave that there. So x to the 0 equals -1. Okay, so here we have, if we're going down, we have 32 divided by 2 gives me 16, divided by 2 gives me 8, divided by 2 gets me 4, divided by 2 gets me 2, divided by 2 gets me 1. And then we start moving into these decimals. But I'm going to write this differently over here. Instead of writing it like that, what if I wrote it like this? So if I did this one as 8 divided by 2 equals 4. And then 4 divided by 2 equals 2. And then 2 divided by 2 equals 1. So then this would be 1 divided by 2 equals 0.5. Okay? And then this would be 1 divided by 4 would be 0.25. So think about that. 1/4 is equal to 0.25, right? We know that. And so the next one would be 1 divided by 8 equals 0.125. And then 1 divided by 16 is this one. And 1 divided by 32 is that one. So what written as a fraction form, what you might start to notice is these denominators are the exact same as these numerators over here. So that bottom one down there that I couldn't figure out in my head, which I've now written, is 1/64. So this one here is 1/64. Okay? So that's kind of interesting. And it doesn't show up if we write our answers in decimal form. So if we write our answers in decimal form, all we see is 0.5, 0.25, 0.125. When we write our answers in fraction form, I'm going to go here like this. So that's 1/2. And then I'm going to clean it up, I think. Maybe make it show up a little bit easier here. So this one is 1/2. This one is 1/4. This one is 1/8. This one is 1/16. This one is 1/32. See that? See how that works? So each of these denominators are one of these factors up here. So that corresponds with this. If I look at the 2 cubed, right? 2 cubed is right here. That's 8. And 2 to the -3rd is 1/8. 2 to the -4th, we're saying is, where's that one at? 16. So that's 1/16 right there, right? So 2 to the -4th is 1/16. 2 to the 4th is 16. So we can easily understand that when we have negative exponents, what they're really telling us is that I have a fraction of a number. I don't have a whole number. I have a fraction of a number, okay? So what I'm going to do over here, I'm going to slide over, and I'm just going to put some exponents on the board, and all you're going to tell me is what you know about the number, okay? So you're going to tell me, is the number bigger or smaller than 1? Okay? So that's it. Is the number bigger or smaller than 1? All right, so here we go. Is that number going to be bigger or smaller than 1? Okay, so I'm going to just write a couple up here, and you tell me if it is bigger or smaller than 1. Oops, I don't know why I did 3 twice. Okay, so there you go. So you're looking at these numbers here, and all you're saying is this number is going to be bigger or smaller than 1. And I'll give you guys a chance to do those, and then I'll go ahead and put the answers. You might want to pause and then go ahead. Okay, so if we look at number 1 here, this answer, whatever that is, I don't care what it is, but whatever it is, it's going to be bigger than 1. And how do I know it's bigger than 1? Because this is positive. Okay? Then I look at the next one. This one here, this number is going to be smaller than 1, less than 1. And how do I know that? It's because it's negative. It does not mean that's a negative answer. It's not a negative number. It's just a fraction of 1. It's like 1/3 or 1/7 or 1/9, something like that. This one is going to be less than 1. Same thing. The reason it's less is because it has a negative exponent. This one here is going to be bigger than 1 because that's 10 to the 5th. So this is going to be bigger than 1. All right. This one is really tricky because we don't know what the number is. So the only thing I can be looking at is the exponent. And so that exponent is going to be less than 1 because that's a negative number. Okay, so that's less than 1. And then the bottom one down here is z to the 0. Well, is z to the 0 bigger or less than 1? And it's neither because it's equal to 1. All right, because anything to the 0 power is equal to 1. Okay? Okay, perfect. I'm going to do the same thing, except we're going to do it in reverse, right? So I'm going to put up new problems up here, and you're just going to tell me what you know about the exponent. Okay, whatever the exponent might be. I'm going to go ahead and pause it. Okay, so this is the last part of the first video here, and all I want you to tell me is the exponent going to be a positive number or a negative number? Based on the information that's given to you, is the exponent going to be a positive or a negative? So go ahead and press pause for a second and write those down. Again, you do not need to upload these. These are just for practice in the lesson today. Okay, so hopefully you had a chance to determine if there's going to be positive or negative. So I look at this one right here, and 3.42, that exponent is going to be positive because 3 is bigger than 1. Okay? This next one here, number 2, is going to be negative. And the reason it's negative is because that number there is less than 1. Okay? The next one here, number 3, is positive because 16 is bigger than 1. The next one is negative because this number is less than 1. The next one is positive because this number is bigger than 1. The next one is actually going to be equal to 0, right? It's neither positive or negative. Technically, it could be equal to 1, right? But it's not going to be bigger or smaller than 1. So it's neither. And how about number 7? 7's kind of a tricky one. What's the exponent going to be for number 7? This is one where you're going to go, wait a minute, you said it has to be bigger than 1. So this is actually going to be positive, right? So what I don't care about is this. So think about really what I'm saying is the absolute value. We haven't talked about absolute value really. We talked about that in a different course. But the absolute value of 14, meaning, so just ignore that. If this were a positive number, is the exponent going to be bigger or negative or smaller than 1? And so since 14 is bigger than 1, it's going to be a positive exponent. Okay? So what I don't want you to think at all is that negative exponents mean negative answers. Negative exponents mean fractions of 1. So a decimal or a fraction, okay, less than 1. Okay, that's the first part of the lesson for today, and I'm going to go ahead and hit stop and upload this and then start the second lesson.